Okay, welcome back. We're going to begin our next chapter, Chapter 7. And Chapter 7, in my opinion, is probably by far one of the most important chapters in your mathematical, set of skills. What we're going to be doing in Chapter 7, all of Chapter 7 is going to be carried throughout Chapter 8 as well, okay? And the skill that you learn in Chapter 7, you will also be using a great deal should you take other higher level math courses, whether it be pre-calculus or calculus. The skill that you will be learning here in Chapter 7 is essential, and you will continue to use it in your other higher level math courses. And the skill that I'm referring to is the skill of factoring. Factoring is a fancy word that we use when we talk about division, okay? In one of the earlier sections in Chapter 6, I believe it was maybe 6.4, where we looked at multiplying polynomials, okay? What you're going to be doing, like for example, if I gave you x plus 3 times x plus 4, and you may recall in Chapter 6 we learned how to multiply these together. And when you multiply, you formed another polynomial of x squared plus 7x plus 12. And remember, you did that by foiling. That was the acronym that we used to describe how to multiply those together. Well, in Chapter 7, one of the main things that you're going to learn to do is how to go from the trinomial here, this polynomial of x squared plus 7x plus 12, and you're trying to create and come up with these two polynomials that would have to get multiplied together. And when you go in that opposite direction, that's what we call factoring. Okay, that's going to be a key component in Chapter 7. All right, when we go in this direction, that was multiplying. But when we are going in the opposite direction, we consider that factoring. So that's why I say factoring is really division, because it's the opposite operation. So factoring really is division. Okay, and we already talked a little bit about how to divide polynomials, and this is going to just expand upon that. All right. Now, one of the first things, okay, when factoring polynomials, I'm going to give you a series of steps that we're going to be talking about when we talk about factoring polynomials. And each section in Chapter 7, I'm going to expand upon these steps. So, first of all, in step 1, when you are factoring polynomials, what you want to do is you want to put the polynomial in descending order. Now, in order for us to put a polynomial in descending order, what you have to look at are the exponents, the powers. And you want the exponents, the powers of your polynomial to decrease by the numbers. So for example, let's say we had a 5x squared minus 7x plus 2. This is in what we would call descending order. Why? Because we look at the exponents. We have an exponent of 2, we have an exponent of 1, and technically we have an exponent here of x to the 0 power. Okay, anytime there's a constant, there is technically an x to the 0 power. All right, and so if we look at the exponents, it goes from an exponent of 2 to 1 to 0. This is considered descending order, and this is what you want. You want your polynomial to be in descending order. All right, let's say we had this. What if we had, let's say, 3x plus x squared plus 5? This is not in descending order. Why? Because if we look at our exponents once again, the first term has the variable x to the understood first power. Then it goes up to x squared, and then it goes back down to the understood x to the 0 power. So what you would want to do is you would want to change up the order, okay? In which case you would write x squared first, then you would follow it up with the 3x, and then you would follow it up with the positive 5. And now this is considered in descending order, which is what you want, okay? You always want, your very first thing is to put your polynomial in descending order. Largest exponent down to the smallest exponent. That's very, very important when it comes to your factoring of polynomials. Now, your second step that you want to do, that you want to look for, is you want the leading coefficient to be a positive number. So you want your leading coefficient should be positive. For example, let's say we have maybe a 3x squared minus 7x plus 2. Well, first of all, is the polynomial in descending order? Yes, it is. The leading coefficient should be positive. Well, what's the leading coefficient here but the number 3? Okay, once you know your polynomial is in descending order, the leading coefficient is the exponent, the number that's being multiplied with the variable. And here our leading coefficient is a positive 3, so we're good. Okay, for example, let's take a look at another one. Let's say we had 5 minus 8x plus x squared. Okay, once again, the first thing that we would want to do is look to make sure our polynomial is in descending order, and it's not. So what I have to do is I have to change around my order. I'm going to start with x squared. That's the highest power. Then I'm going to go to the negative 8x, and then I'm going to go to the positive 5. So now my polynomial is in descending order. Now I'm going to check, is the leading coefficient a positive number? Well, here my leading coefficient happens to be the number 1, and it's a positive 1. So my leading coefficient is positive. So we're good there, all right? So that takes care of step 2. We'll talk about what happens if your leading coefficient is a negative number. What we have to do something special, okay? So that takes care of steps 1 and 2 for the time being. So now let's talk a great deal about step 3. The third thing that you're going to do when you are factoring polynomials. After you put the polynomial in descending order, and after you have checked that your leading coefficient is a positive number, what you're going to look to do is you are going to now factor out the greatest common factor. Okay, and we're going to spend a great deal of time on what's called the greatest common factor here in section 7.1. I usually abbreviate greatest common factor as the GCF. Okay, that's the common abbreviation for greatest common factor. Now there are all different types of greatest common factors, and we're going to look at them one by one. For example, let's say we had the following: 6x squared plus 10x minus 4. Now, looking at this polynomial, first of all, it is in descending order. My leading coefficient should be positive, and it is. It's a positive 6. So we're good with steps 1 and 2. Now what we're going to look to do is factor out a greatest common factor. And the first type of greatest common factor that we're going to be talking about is a constant. okay? These three terms of this particular polynomial have a greatest common factor, a constant. What number, I am taking a look here at the 6, the 10, and the 4, and I am looking to see if there's a number that can go into 6, 10, and 4 equally, okay? Evenly, I should say. And there is. The largest number that can go into 6, 10, and 4 evenly happens to be the number 2. 2 is your greatest common factor. Now here's what we do with greatest common factors. You take the common factor and you're going to place it outside a parenthesis. And then what you have to do is you have to divide each term by that greatest common factor. Because remember, factoring is division. 6 divided by 2 would leave us with a 3x squared. 10x divided by 2 would leave us with a plus 5x. Negative 4 divided by 2 leaves us with a negative 2. And this would be the factored form of your polynomial. Okay? We have put the polynomial in descending order. Our leading coefficient was positive. Okay, it was that positive 6. But we noticed that there was a greatest common factor, a common constant that we could factor out, and it happened to be the number 2. What do we do with that greatest common factor? I said bring it outside a parenthesis. And then you have to divide each of those terms by the greatest common factor. 6 divided by 2 is 3. 10 divided by 2 is 5. The negative 4 divided by 2 gave you a negative 2. Okay, we have divided by 2. How do we know this is correct? Well, remember, if factoring is division, you can always check your answer by multiplying. If you multiplied the 2 with the 3x squared, you would get back the 6x squared. If you multiplied the 2 with the 5x, it would bring you back to the 10x. And of course, if you multiply 2 times the negative 2, you would get negative 4. So it would bring you back to the original polynomial should you multiply things back together. Let's do another example. Let's say we had 24x squared minus 48x minus 60. Once again, put the polynomial in descending order. It is. Step 1's done. Step 2, the leading coefficient should be positive, and it is. It's a positive 24. Now we're up to step 3. Is there a common factor? And right now we're talking about a common constant. Is there a number that goes into 24, 48, and 60 evenly? And the answer is yes, there's quite a few numbers. Okay, if you think about, if you are comfortable with your multiplication tables and division skills, you would know that 2 will go into all 3 numbers. The number 3 will go into all 3 numbers. The number 4 will go into all 3 numbers. But remember, we are looking for the greatest common factor. 6 will go into all 3 numbers evenly. However, if we were to identify the greatest common factor of these 3 terms, we know here that the 24, 48, and 60 are all divisible by the largest number, 12. So 12 is the greatest common factor. Now remember, we take the common factor, we put it outside a parenthesis, and now we're going to have to divide the 12 into all 3 numbers. When we do 24 divided by 12, that gives us a 2x squared. When we divide the negative 48 by the 12, that gives us a minus 4x. And if we were to divide the negative 60 by the 12, that would give us a negative 5. And that would be your factored expression. Okay, we went through these 3 steps. where we made sure it was in descending order. We made sure our leading coefficient was positive, as well as we took out a greatest common factor, a constant, which happened to be, in this particular case, the number 12. I want to take a look at another one, maybe one that involves, let's say, all three steps. Let's say you are going to be asked to factor the 18x plus 21 minus 9x squared. Okay. Well, here we have to perform step 1, because right now this polynomial is not in descending order. So I'm going to write this as a negative 9x squared. Then I'm going to follow it up with an 18x and then a plus 21. So that takes care of step 1. Step 2, the leading coefficient should be a positive number. And if we look here, the leading coefficient is this negative 9. So that we're going to have to address. We need to change this leading coefficient from a negative number to a positive number. So that's going to affect step 3. Let's take a look at the three numbers, 9, 18, and 21. Now, here in this particular case, the greatest common factor happens to be the number 3, except because this leading coefficient right now is negative, the greatest common factor is not going to be a positive 3, but a negative 3. So what do? We take the greatest common factor, we place it outside the parenthesis. I'm going to say that a lot. Take the greatest common factor, place it outside a parenthesis, and now we have to divide all terms by that greatest common factor, negative 3. And so now when I do my division, negative 9 divided by the negative 3 would give you a 3x squared. Now we see here that the leading coefficient is positive. Don't worry so much about the fact that there's a negative 3 outside, but the greatest common factor, the leading coefficient of the polynomial is now a positive 3. If we take the positive 18 and divide it by the negative 3, of course that would give you a negative 6x. As well as if we take the positive 21 and divide it by the negative 3, that would give you a negative 7. Now that we have factored out the greatest common factor, the negative 3, now we have our factored form of our polynomial. Okay? If we wanted to check it, I would have to multiply my negative 3 back on all three terms, and that would take me back to the original polynomial, as it always should. Okay? In all these examples that we did, the greatest common factor was a simple number. It was a constant. Okay? I want to take a look at a different kind of greatest common factor. For example, let's say we had the following. Let's say we had maybe a 7x to the 5th plus a 10x to the 3rd minus a 14x squared. Well, the polynomial is in descending order. My leading coefficient should be positive, and it is. It's a positive 7. Factor out the greatest common factor here now in step 3. Well, is there a common constant that goes into 7, 10, and 14 to all three terms? The answer is no. Okay. But now let's take a look here at these three terms. They do share something in common. Okay? They have a common variable. All three terms, notice here, have an x. This term has an x. This term has an x. and this term also has an x. So there is a common variable. And when you have a common variable, the greatest common factor is going to be the variable actually with the smallest power. So in this particular case, the greatest common factor would be an x squared, okay? Because this first term here has at least two x's. This has at least two x's, and this also has at least two x's. So that is the greatest factor that they have in common. What do we do with the common factor? As always, we take the common factor, and I have to place it outside the parenthesis. And now I have to go and I must divide, just like we did in the previous examples, all three terms by the x squared. Now remember from our laws of exponents that when we divide the variables, we have to subtract the powers. So I'm going to have left over a 7 x to the third, a plus 10 x minus 14. We have now the factored form of the original polynomial. Once again, if I was to multiply the x squared back into the trinomial, it would bring us back to the original. Okay? So once again, here, very carefully, what did we have here but a common variable? And whenever you have a common variable, you always go with the smallest power. Let's try another one. Let's say we have maybe a 5x to the fourth, y to the second, plus 8x to the third, y, minus, let's say, 7x squared, y to the fourth. Okay. We're looking to factor out the greatest common factor. Now, once again, there's no common constant. So let's look at our variables. We have multiple variables here. We have an x in each of the three terms, and we have a y in each of the three terms. But when it comes to your variable, you want to go with the smallest power. So let's start by looking at my x's. And as I look at my x's, the smallest of all the x's would be x squared. Next, I have to look at my y's. When I look at my y's, the smallest power of my y's would be simply y to the first. So the greatest common factor would be an x squared y. What do we do with that greatest common factor? I'm going to take it, and I'm going to place it outside the parenthesis, and then I must go and divide all three terms by that greatest common factor of x squared y. So, if I take the 5x squared y squared and divide it by the x squared y, that would leave me with a 5, and now I'm going to have an x squared y left over. Because remember, I have to subtract these powers. Plus, if I'm going to take now the 8x cubed y and divide it by x squared y, that would leave me with an 8. And when I divide my variables x, I get x to the first. And when I divide my variables y, y divided by y is simply 1. Minus, now let's take the 7x squared y to the fourth and divide it by x squared y. Well, the 7 remains. X squared divided by x squared, that simplifies to 1. And y to the fourth divided by y would give us a y cubed. And that would be your factored form of that polynomial. Okay? So here, once again, we saw that there was a common variable. Okay? Let's take a look at another type of greatest common factor. There's all different types that we can encounter. For example, let's say we had the following. Let's say we had a 16x cubed, a plus 20x squared, and a minus 4x. Well, if we go through our steps, it is in descending order. Exponent of 3, 2, 1. Leading coefficient should be positive, and it is. Now let's go to our factoring out the greatest common factor. Well, here we have a slightly different kind of greatest common factor. Here, not only do we have a common constant, because I look at these three numbers of 16, 20, and 4, and I see that they're all divisible by 4, but there is also a common variable because all three terms have a common x. And when that happens, when you have a common constant and variable, now we say that there's a common monomial. So the greatest common factor here happens to be the monomial of 4x. So what do we have to do with this? You take the greatest common factor, we place it outside the parenthesis, and now once again I would have to go and divide all three terms by the 4x, that common monomial. Let's perform our division now. 16x to the third divided by 4x would give us a 4x squared. The positive 20x squared divided by a positive 4x would give us a plus 5x, minus 4x divided by 4x is simply the number 1. And this would be your factored form of the original polynomial. Because here we were able to take out, factor out, divide out a common monomial made up of the constant 4 as well as the variable x that are being multiplied. Okay? Let's try another one. Let's say we have the following. Let's see how many things we can pull together into one type of a problem. What if we had, let's say, a 20x to the third minus 40x to the fifth minus, let's say, 50x to the seventh. Okay. We want to factor this completely. Well, first and foremost, we have to put this in descending order of powers because my largest exponent is at the very end. So I'm going to have to write this as a negative 50x to the seventh, a minus 40x to the fifth, and a plus 20x to the third. So step 1 is done. Step 2, we want the leading coefficient to be a positive number, and right now it's a negative 50, so that's no good. Okay, so that's going to affect step 3. The greatest common factor. Okay. Well, let's take a look first of all at the numbers. 50, 40, and 20. Okay. 50, 40, and 20 are all divisible by 10. But since we need this greatest common factor to be positive, I'm actually going to factor out a negative 10. There is also a common variable, okay? And if we look at the variables, the smallest power happens to be x cubed. So here the greatest common factor, once again, happens to be a monomial, the monomial of a negative 10 times x to the third. So what do we have to do? I'm going to take that greatest common factor, and once again, I'm going to place it outside of a parenthesis, and then I'm going to proceed to divide all three terms by the negative 10 x cubed. If you have trouble with division or even multiplication, use your scientific calculator. Now let's go and divide. Negative 50 divided by the negative 10 would give us now a positive 5. And if I was to divide the variables, x to the 7th divided by x cubed is x to the 4th. The negative 40 divided by the negative 10 would give us a plus 4. And x to the 5th divided by x cubed would give us an x squared. And then carefully here, the positive 20 divided by the negative 10 would give us a negative 2. And x cubed divided by x cubed, of course, is the number 1. And that would be your polynomial expression in factored form. It's the same thing, okay? It's just written as a product of two quantities as opposed to the full polynomial. We're not changing the value of anything, we're just changing the way things look, okay? We have one more type of greatest common factor to talk about, okay? We've seen if we have a common constant, a common variable, or a common monomial, which, remember, once again, is a product of constants and variables. Okay, if we have a product of constants and variables, that's what we call a monomial. Now, the last type of greatest common factor that we have to address here in our very first section of Chapter 7. For example, let's say we have the following. Let's say we have x to the 5th times x plus 1 plus 2 times x plus 1. Well, here we don't have a common constant. Here we don't have a common variable. We don't even have a common monomial, a product of constants and variables. Instead, what's common? And now actually, here there are only two terms. Let's take a look at what makes up these two terms. The terms are x squared, x to the 5th times x plus 1. That's the first term. And the second term is 2 times x plus 1. Those are the two terms separated by the plus sign of this polynomial. Now, if we look carefully at these two terms, we will notice that they have a common polynomial. The greatest common factor here happens to be what we see inside the parenthesis, x plus 1. Notice how I keep it in parentheses. Okay, we want to keep your polynomial group together. Remember, what do we do with the greatest common factor? You always take your greatest common factor, which in this particular case is x plus 1, and I need to place it outside a parenthesis. And then what did we do? We took each term and we divided it by the greatest common factor. If I take the x to the 5th times x plus 1 and divide it by x plus 1, you are simply left with x to the 5th, because these simplify. Plus, if I take 2x plus 1 and divide it by x plus 1, x plus 1 over x plus 1 simplifies, leaving us with just the number 2. And that is your factored form. Once again, we were able to factor out a common polynomial. Let's take a look at another one. Let's say we have 3x times x squared plus 1 minus 4 times x squared plus 1. Once again, we have here a common polynomial between these two terms, and that greatest common factor once again happens to be the polynomial of x squared plus 1. So we take that common factor of x squared plus 1, and when we place it outside the parenthesis, I now have to go and divide each of the two terms by that greatest common factor. When we perform the division here, we are simply left with a 3x. When I perform my division here, we are simply left with a minus 4. And that would be your factored form of that original polynomial. Okay? So steps 1, 2, and 3. Okay, very, very important steps. Always make sure that your polynomial is in descending order. Make sure your leading coefficient is positive. And then you are going to proceed in step 3 to look for the greatest common factors. They could be constants, just numbers. They could be a variable. If there is a common variable, you go with the smallest power. It could be a monomial. What's a monomial? Once again, it's the product of constants and variables. Or, as we saw in these last two examples, it could be a polynomial. Now, there's one more thing that I have to talk about here in section 7.1. Okay, it's a different type of factoring. Okay. It's going to be our fourth step. After we have done steps 1, 2, and 3, and I'm going to recommend that when you are factoring polynomials that you go through these steps one at a time. So after you go through step 1, after you have checked step 2, and you have done step 3, step 4, we are going to use when we have a 4-term polynomial. If your polynomial is made up of 4 terms, what you are going to do is a different kind of factoring. You are going to factor by grouping. Okay, so let's spend some time taking a look at this, for example. Let's say we have the following: x cubed plus 2x squared plus 3x plus 6. Step 1. Is your polynomial in descending order? Yes, it is. Step 2. Is your leading coefficient positive? Yes, it is. It's a positive 1. Step 3. Is there something common? Is there a greatest common factor, whether it be a constant, variable, monomial, or polynomial, to all 4 terms? The answer is no, there's nothing common. So we have checked out steps 1, 2, and 3. And now, because it is a 4-term polynomial, we're going to proceed to factor by grouping. So let's take a look at, first of all, just the first 2 terms. Okay, we're going to group the first 2 terms together, and we're going to ask ourselves if the first 2 terms have a greatest common factor. Just the first 2. And the answer is yes. There is a common variable. These first 2 terms have a common variable, so we go with the smallest power of x squared. That is your greatest common factor of just the first 2 terms. So what do I have to do? I have to take the greatest common factor, and I'm going to place it outside the parenthesis, just like we've been doing, and then I have to divide each term by the x squared. When you divide x cubed by x squared, you get x. When you divide 2x squared by x squared, you get a plus 2. So we have factored out the greatest common factor out of the first 2 terms. But now what you want to do is you want to go to and group the next 2 terms together. And when we group the next 2 terms together, you're going to ask yourself, do they have a greatest common factor? And looking at these 2 terms, they do. They have a common constant of a positive 3. And once again, what do we have to do with the greatest common factor? You're going to take that positive 3, you're going to place it outside the parenthesis, and then you're going to have to divide each term by the 3. If we take 3x divided by 3, you get x. If you take the 6 divided by 3, you get a plus 2. And so now, what we have done is we factored out the greatest common factor out of the first 2 terms. Then we factored out the greatest common factor out of the second 2 terms. We no longer have a 4-term polynomial. Instead, we have this 2-term polynomial. Now let's take a look at these 2 terms. Now if I take a look at these 2 terms, I'm going to ask myself, do they have a greatest common factor? And sure enough, they do. These 2 terms, if I look real carefully, have a greatest common factor, the polynomial x plus 2. What do we do with this greatest common factor? Well, always take the greatest common factor, and what you have to do is you place it outside the parenthesis, and now I have to go and divide each of these 2 terms by that greatest common factor. If I take this first term, x plus 2 divided by x plus 2, simply leaves me with x squared. If I take the 3 times the x plus 2 and divide it by the x plus 2, that will leave me with simply with a plus 3. This is your factored form of the original polynomial. If I was to multiply this back together, it would bring me all the way back to the original polynomial, because they are equivalent. Just one is in multiplied form, the other is considered the factored form. And the factored form is going to be very helpful to us, not only here in chapters 7 and 8, but also throughout your mathematical careers in your higher level math courses. Okay? Let's try another one. Let's say we had the following. What if we had a 2x to the third plus an 8x squared minus x minus 4? Okay, it's in descending order. My leading coefficient is positive. Next, we look at our greatest common factors. Step 3, there is nothing common to all 4 terms. But because it is a 4-term polynomial, I'm going to look to once again factor this by grouping. So I'm going to group the first 2 terms together, and I'm going to identify their greatest common factor. And they do have a greatest common factor. It happens to be a monomial of a 2x squared. That's the greatest common factor. So I take the greatest common factor of 2x squared, and I place it outside the parenthesis, and then I have to divide each term by the 2x squared. When we perform our division here, 2 divided by 2 is 1. X cubed divided by x would leave us with an x. When I perform the division here, 8 divided by 2 would be a plus 4. And x squared divided by x squared, it simplifies to the number 1. So that took care of the first 2 terms. Okay. Next, what we want to do, once again, is we want to group the next 2 terms. And we're going to look to see if the next 2 terms also have a greatest common factor. Now, you can kind of cheat a little bit in the sense that after you did your first problem, look to see what's left in the parenthesis. Okay? What's left here is the x plus 4. So I need to factor something out of the next 2 terms that would leave me with an x plus 4. Okay? Well, the only thing that these 2 terms have in common is a negative 1. okay? So just like before, I'm going to have to take the greatest common factor of a -1. I'm going to place it outside the parenthesis, and now I have to divide each term by the -1. When I take the -1 and divide it, or I take the negative x and divide it by the -1, we get x. If I take a -4 and divide it by a -1, we get a +4. Okay? And if you look at the parentheses, what's left is you'll notice in these two terms, they too have a greatest common factor. They have a common now polynomial of x plus 4. Okay? Once again, what do we do with that greatest common factor? You take the greatest common factor, you place it outside the parenthesis, and then once again you have to divide by that greatest common factor. When I perform my division here, you're left with simply a 2x squared. When I perform the division here, okay, I will be left with a -1. And this would be the factored form of the original polynomial. Okay? Remember, factored form, all we did was perform division. Okay? If I was to multiply this back, it would take me all the way back to the original polynomial. Okay? That's how you can always check your answer. All right? Let's just see that. Let's see if I was to multiply these things back together, if it would bring me back to the original. So if I multiplied x times 2x squared, that would give you a 2x to the third. If I now multiplied the 4 times the 2x squared, that would give you a plus 8x squared. Next, let's multiply the x with the -1. And that would give you a -1x. And then finally, we would have to multiply the 4 with the -1, and that, of course, would give you a -4. So it does bring you back to the original polynomial, as it should, okay? Because all we did was divide to form this factored form of the polynomial, okay? Those are the first 4 steps of factoring, okay? That completes section 7.1. Okay, there's a lot of information there, a lot of important information, okay? When we come back the next time, we're going to take a look at section 7.2, which primarily focuses on factoring trinomials, 3-term polynomials, all right? So take a look at the homework that goes along with section 7.1, and feel free to give me an email, shoot me an email with any questions or concerns you may have. Until the next time, be well.